Every single week, somewhere behind massive steel doors and miles of automated conveyor belts, enough Pantene shampoo bottles are produced to fill entire supermarket aisles across America, Europe, and Asia at the same time. In one section of the factory alone, robotic systems move faster than human eyes can comfortably track, blasting out thousands of perfectly shaped plastic bottles every single hour without stopping for days. But hidden inside this enormous operation is one machine so expensive and so precise that a mistake lasting less than 30 seconds can destroy hundreds of thousands of dollars in product almost instantly. And the craziest part is that most people using Pantene every morning have absolutely no idea how extreme the process really is. The scale starts long before the shampoo even exists. Massive industrial tankers arrive carrying concentrated chemical ingredients that look nothing like the silky liquid people pour into their hands at home. Some are thick like glue. Others are crystal clear. Some are stored at carefully controlled temperatures because even slight changes in heat can ruin the formula before production begins. Inside giant stainless steel storage rooms, computerized systems monitor pressure, viscosity, and chemical balance 24 hours a day. One wrong measurement here and millions of bottles could fail quality testing later. That is why every ingredient entering the plant is scanned, tested, and digitally tracked before it touches the production floor. And this is where things start getting insane. Deep inside the facility, gigantic mixing tanks tower several stories high. Each one can hold enough shampoo to fill thousands of bathtubs at once. Massive industrial blades spin inside these tanks with incredible force, blending ingredients into the smooth formula recognized by millions of customers worldwide. But the process is far more delicate than most people realize. If the mixing speed is too aggressive, air bubbles form inside the shampoo. If the temperature drifts too high, the texture changes completely. And if the timing is even slightly off, the final product may separate weeks later while sitting on store shelves. Workers monitor everything from elevated control rooms, packed with glowing screens and flashing data streams. But despite all the automation, some of the most important quality checks still depend on trained human senses. Technicians physically inspect the texture between their fingers. Others analyze scent consistency because even tiny fragrance variations can trigger entire product rejections. What looks like ordinary shampoo is actually the result of industrial precision closer to pharmaceutical manufacturing than most people would ever expect. But the shampoo itself is only half the story. Because while the liquid is being prepared, another side of the factory is already creating the iconic Pantene bottles at unbelievable speed. Mountains of tiny plastic pellets arrive in bulk containers so large they resemble train cars. These pellets are vacuum-fed into injection molding systems, heated to extreme temperatures until the plastic becomes molten. Then comes one of the fastest manufacturing processes in the entire consumer goods industry. Blow molding machines fire into action with violent bursts of compressed air, transforming glowing tubes of molten plastic into perfectly shaped bottles in seconds. Entire rows of robotic arms move in synchronized patterns, grabbing fresh bottles while they are still warm and transferring them onto conveyors with machine-level precision. Some systems operate so quickly that they can produce more bottles in a single hour than a small factory could make in several days. What happens next is unbelievable. Every bottle is instantly scanned by high-speed cameras capable of detecting microscopic defects invisible to the human eye. A slightly warped neck, an uneven wall thickness, a tiny crack smaller than a grain of sand. The defective bottle is automatically blasted off the conveyor before anyone even notices it existed. Thousands of these inspections happen every minute, and this tiny detail changes everything. The bottles are intentionally designed to survive brutal transportation conditions most customers never think about. They must withstand warehouse heat, freezing delivery trucks, pressure stacking, vibration during shipping, and accidental drops in stores. Engineers spend years refining bottle flexibility because if the plastic is too rigid, it cracks. Too soft, and it collapses during packaging. Something as simple as squeezing shampoo in the shower actually depends on millions of dollars of industrial engineering research. Then comes the filling line, which feels less like a factory and more like a futuristic machine city. Endless rows of empty bottles race down conveyors at astonishing speeds, while synchronized filling nozzles descend with terrifying accuracy. Each nozzle dispenses the exact amount of shampoo in fractions of a second. Not slightly more, not slightly less. Because when millions of bottles are produced every week, even tiny overfills can waste enormous amounts of money over time. The sound inside this area is deafening. Motors roar constantly. Conveyor systems rattle across steel platforms. Pneumatic systems hiss in rapid bursts. Warning lights flash overhead as workers move carefully through designated safety zones. Some filling lines are so fast that if a single bottle tips over, the resulting collision can create a chain reaction capable of shutting down production instantly. And every second the line stops costs enormous amounts of money. But this is where the hidden secret of the entire operation finally appears. Near the center of the production floor sits a massive computerized control system connected to nearly every machine in the building. It tracks bottle speed, liquid pressure, labeling alignment, cap torque, conveyor timing, ingredient flow, and even microscopic vibration patterns inside certain motors. This system predicts failures before they happen. In some cases, it can identify a machine component wearing out days before human workers notice any issue at all. Because when production runs at this scale, downtime becomes catastrophic. A single hour of shutdown can delay shipments to thousands of stores worldwide. Entire logistics networks depend on these factories operating almost continuously. Trucks line up outside loading docks day and night while warehouses coordinate inventory across multiple countries at once. Some retailers receive shipments within hours of production completion, and then comes one of the most satisfying parts of the entire process. The labeling systems. Bottles moving at incredible speed pass through rollers and laser-guided alignment machines that apply labels with near-perfect precision. If a label is even slightly crooked, automated scanners instantly reject the bottle. Watching thousands of bottles glide through this section looks almost hypnotic. The synchronization is so precise that it barely feels real. Right in the middle of all this chaos, here is something most viewers never expect. Even with billions of dollars in automation, skilled human workers still make the difference between smooth operation and complete disaster. Experienced technicians can sometimes detect machine problems simply by listening to subtle changes in sound. Others know exactly how environmental humidity affects packaging performance. Some workers spend years mastering a single production system because one incorrect adjustment could ruin massive batches of product. And if you are enjoying seeing how insanely complex something as simple as shampoo really is, hit like and subscribe, because what happens near the end of this process becomes even crazier. After filling and sealing, the bottles move toward automated packaging zones where robotic systems group products into perfectly arranged bundles. Mechanical arms lift entire rows at once with incredible speed, stacking them into shipping cartons that are instantly sealed and coated for global distribution. Some robots operate continuously for hours without a single pause, repeating movements with precision impossible for humans to maintain manually. But hidden behind this efficiency is a constant battle against contamination. The factory is obsessively clean because even tiny particles can compromise entire production runs. Air filtration systems run nonstop. Certain areas maintain controlled pressure environments to reduce dust intrusion. Workers follow strict sanitation protocols before entering sensitive sections. Some machines are cleaned using automated systems that flush internal pipes with heated sterilizing solutions between production cycles. The amount of waste management involved is another shocking reality most people never consider. Defective bottles, excess plastic trim, rejected labels, leftover product, damaged packaging, and cleaning residue all create enormous industrial waste streams. Modern factories spend millions developing recycling systems that grind rejected plastic back into reusable material. Water treatment systems process huge amounts of industrial wastewater before release. Sustainability has become a massive economic issue because reducing waste even slightly can save enormous amounts of money across millions of units. And this is where the numbers become almost impossible to comprehend. Some major personal care factories can produce tens of thousands of bottles every single hour during peak operation. Over the course of a week, That becomes millions of products moving through warehouses, trucks, ports, and store shelves around the world. Entire supermarket sections are constantly replenished by these nonstop industrial ecosystems hidden far from public view. But despite all the machinery, one terrifying risk always remains: temperature failure. If cooling systems malfunction during plastic molding, entire production lines can warp within minutes. If storage temperatures shift incorrectly, shampoo consistency changes. If transportation containers overheat, packaging can deform before reaching stores. That is why backup systems exist everywhere. Redundant cooling units, emergency generators, secondary monitoring systems. Some factories even maintain dedicated maintenance crews around the clock because the cost of failure is simply too high. And remember that billion-dollar level machine problem mentioned earlier? Here is the shocking reality. Certain filling systems operate so fast and with such pressure that if synchronization fails for even a brief moment, thousands of bottles can overflow simultaneously, flooding conveyor systems with shampoo in seconds. Cleanup crews train specifically for these disasters because major spills can shut down production and damage sensitive equipment almost instantly. Some workers describe it as a tidal wave of shampoo racing across the factory floor. Yet somehow, despite all this complexity, the finished product still ends up looking effortless sitting quietly on a bathroom shelf. That smooth bottle, shiny cap, and perfectly scented formula hide one of the most advanced manufacturing operations in the consumer goods world. Behind every bottle is an industrial network of chemical engineering, robotics, logistics, predictive maintenance, precision molding, quality science, and nonstop automation running with near-military coordination. And the final hidden fact makes the entire operation even more unbelievable. Many of these factories never truly sleep. Production continues through the night, through weekends, through holidays, because global demand never stops. While millions of people sleep, robotic lines continue forming bottles, blending shampoo, sealing caps, scanning defects, loading trucks, and feeding stores around the world at relentless speed. Entire buildings operate like giant living machines, consuming raw materials and producing endless streams of products every hour of every day. The next time someone casually squeezes Pantene shampoo into their hand, they are touching the final result of one of the most carefully engineered, brutally efficient, and shockingly massive industrial systems hidden behind everyday life.